Hello guys, today I want to cover this problem. This problem number 2 from the last year's IB chemistry higher level exam. It was from paper 2. And let's start. So for the first question, we need to find the secondary amino group. And the secondary amino group is that group that have only one hydrogen around it. So this one and this are both tertiary because they don't have any hydrogens around them. So the answer is this group right here. For the next question, you need to find of carbons that have sp2 hybridization. And basically, sp2 means one double bond. So we need to look at aromatic cycle. And basically, we need to count all of carbons in aromatic cycle like this. And this is going to be 9. So the answer is 9. And other carbons are all sp3, so they don't count. For the next question, we need to find index of hydrogen deficiency, and this index is equal to number of cycles plus number of double bonds. So let's draw this structure more closely with all double bonds. I'm gonna draw only the skeleton of this, and it looks like this. So we have 1, 2 cycles and 5 double bonds. So our answer would be 2 plus 5 is equal to 7. For the next question, we need to compare this bond and this bond. So this bond have an order. We can say that it's not a double bond, but it's not a single bond. It's more like a 1.5 bond because it's in aromatic cycle, right? So it have an order on 1.5, and this is basically a single bond, so its order is 1. And basically, the larger is order, the smaller is bond. So for example, triple bonds is smaller than double bonds, that smaller is single bonds, and 1.5 bonds somewhere about here, right? So this is our explanation. The next question, we need to draw a structure of B, and what we can see is we added this thing, right? So our B is going to be just this molecule, nothing special, and our answer would be basically this molecule right here, nothing special, and one of our hydrogens is reacted with one fluorines and give here hydrogen chloride. So that's what happened. For the next, we need to find the ground state of copper. It's argon 4s1 3d10. Why it's not 4s2 3d9? Because the configuration 3d10 is much more stable, because we will have 5 filled orbitals, and this is much more stable, and that's why one of these electrons is going to the level, and what we have is 3d10 instead of 3d9, as we could have expected. For this question, we need to use this graph. So what we know is the catalyst lowers activation energy. So with no catalyst, it's going to be around here, doesn't matter. And with catalyst, it's going to be lower, so around here, for example. And the last question, we need to explain the effect of a catalyst using this graph. So we can't just say, oh, it lowers activation energy or it provides alternative mechanism. We need to use this graph. And what we can say that this area is the amount of particles that reached this kinetic energy is going to be smaller than this area, of course, with catalyst. And if we have more molecules that reached enough kinetic energy for the reaction, we have faster reaction, and that is the effect of a catalyst for this reaction. That's it for today. I hope you enjoyed this video. Leave your thoughts about this problem in the comments. Thanks for watching and see you next time.